Hello all. Today we are solving Leetcode daily problem, that is split linked list in parts. So here what we are given is we are given a linked list and an integer k, and we need to break down this linked list into consecutive linked list parts. And there is a condition that the parts occurring earlier should have the size always greater than or equal to the parts occurring later. Okay, and no two parts have a size differing by more than one. So these are the 2 points that we need to keep in mind. So what does it say? It says that if let's say suppose we have two sections, that if we have broken the linked list into two sections, one is 4 and another one is 3. So this is fine, that initially what we have, the section that should have the size greater than or equal to the another section. So if I have 4 here, another section could either be 4 or 3. So the difference can't go beyond that, beyond 1. So that is one scenario. Another one is that initially I can't have 3 sized section first and then 4. Always at the left hand side I will be having the larger section. Okay, so let us see this example, understand this. 1 2 3, that is my linked list is given. I have to break down into 5 sections, but there are only 3. So how can I divide it, maintaining those two conditions that I have? This is how I have broken it. Oh, that means that the question needs it that it should be broken into 1 2 3, null and null. So this is how I have this could be broken into 5 parts. Let's see another example. Here I have a linked list of size 10 and k is 3. So how can we divide it? If you think that the basic knife approach that is coming is, I should divide first everything into equally parts, that every k section should have equal elements, and if anything is left over, then that should be added from the left hand side one by one, so that both the conditions are satisfied, so that the difference is 1 and left hand side should have larger sections. So here also the same, 1 2 3 4, that is a segment of size 4, then a segment of 3 5 6 7, and segment of again size 3, that is 8 9 10. So this is how they have broken down. Okay, this is an example that helped me out to finally land to a solution. So let us think that we have a linked list of size 8, and we have to break, and k value is 3, and I need to break it into k sections. So what I thought initially is, let's divide this linked list by k. What that will give me? That will give me this base size. That base size means that at least this will be the sub-segment's size. That means that the array of list node I am returning, so each element will have at least these two nodes, that is base size nodes. So that is simply the size of the linked list divided by the k. So that gives me 2. Another thing I maintained is extras. What is extras? Extras is the remainder values that we'll be getting. So in this case we will get 8 modulus 3, that is 2. So 2 values will be left if I break it down, this linked list, by two elements. So 1 2 3 4 5 6, but 7 and 8 are left, so that are my extras that I have to manage it. So what I thought initially, that I will initialize 3 segments of size 2, and then extras I will be adding to them. So that means that initially it was 2 2 2, but since I had my extras, so and I have to keep in mind that my left hand side should always be greater than or equal to the right hand side, so I will add 1 and 1, and depending upon how many extras I have. So finally I will conclude this, that the subsegment will be 1 2 3 4 5 6 and 7 8. Okay, so I hope this gives you a bit clarity of what I'm trying to do. If not, do comment it out. I try to again explain it in a better way. I'll quickly show you my C++ code that might help. Okay, so what I did, I took a current pointer that is pointing to head, and I have created a vector of type list node, because in that type I have to return my answer. So what I did, I simply iterated over the entire linked list and calculated the size of it. That the CTR is my counter, how many nodes are there. I maintained a base size and extras by, as I explained in this figure, that how I'm calculating them. Okay, so what I did is I have to manage a base edge case also. The edge case as given in the first example, that what if my base size is 0, that is my k is greater than equal greater than the number of elements I have in my linked list. In that case, I know from the example also and from the logic that we concluded that each segment should have one elements in it, and the remaining will have the null to them. That is, we don't have any value left, so we'll be adding null. So that is what I did. I implemented it. I created a temporary variable that is pointing to current of next, so that I keep the track. Like going forward, I need current of next, because here I make current of next as null. Okay, because I need to push back 1, then 2 and 3. So these are independently I have to add, so that is why I keep track of them. That is pointing to current of next, because I will be updating current of next and I don't lose track of what's the next element. So that is why this is how I have done, and for going forward also I have maintained the same. So I keep on adding, pushing back the current pointer to my answer, and then when I run out of the nodes in the linked list, I simply go and check that whether my size reaches to k or not. If not, then keep on pushing back the null value. So this is how I manage the edge case of when the base size is 0. But when base size is not 0, I took another variable element that is checking that how many current elements I have in bag, and that bag, when that size reaches to base size, what I need to do is I need to check whether I have extras or not, as we did here. So when base size is reached, you check for extras. If extras are there, you take another node to it and then move to another one. If not, so similarly, if extras are there, I updated that extra subtract one because I'm dealing with it. What I did, I moved current to current of next. As in this example, I was here as 2, I moved to 3, and then what I did, I again maintained a temporary variable for current of next. So my current of next is now 4, and I broke current of next to null in order to update my answer, and again updated current and position in order to retrieve this 4 node that I had. So this was when I have extras. If I don't have extras, I don't need to move to current of next. So as you can see here, I haven't moved to current of next. I remain seated at the current. I again took the snapshot of the current of next so that I can update it later. I updated my current of next to null, added it to answer, and again retrieved the cases that I had. So this is when it matches base case. If it does not match, keep on incrementing the element and move to current of next. And when my current hits the null, then which means that we are out of the nodes in linked list, then we simply return the answer. So yeah, this was my basically the solution, and it got accepted. If you all have any queries, please do reach out to me, do comment it out, and do subscribe for more content like this. Thank you.